We're going to continue working with exponents, this time looking at a special group or a specific group of exponents and a unique group of numbers that are called perfect squares. All right, we're going to look at squares and square roots. All right, first of all, these numbers, they're called squares because they do just that. They make a perfect square. If you remember your formula for area, it's length times width. All right, a square has the same length and the same width. All right, and that's where this term of square numbers comes from. It's looking at numbers that will make a square. All right, so what numbers will make a square? Well, if we go back, here are some examples. We have the number 9, for example. I can make a square out of 9 because I can do 3 times 3, and its area, if I have a 3 by 3 square, its area is 9. I can make a square out of 16. Same idea. This time, its area will be 4 by 4. As we'll find out in a bit, that's where the term square root comes from. Right? So that's where these ideas of square numbers comes from. If we take a look, what we're really doing when we say what is a square, we're looking at what's the area of that number. So you can see the area of a square at the right is 5 times 5 by 5, or 25 square units. The product of a number and itself is the square of that number. So we say the square of 5 is 25. And you can see that in this picture here. The square of 5 is 25. And we can find the square of any number. A few examples I have down here at the bottom of this page. For example, what would be the square of 8? What we're saying is if I take a square that is 8 by 8, what's its area? Well, we know that area equals length times width, so we're saying 8 times 8 is 64. 8 squared is 64. Now to go back to our lesson on exponents, and the reason this ties in with exponents is we can write this, because it's 8 times 8, we can write this as 8 to the power of 2. 8 to the power of 2 is the same thing as 8 squared because it makes an 8 by 8 square. The area of that square would be 8 times 8, or 64. Let's look at another example. Same concept, different numbers. This time I want to know what's the square of 12. So now I have a square that is 12 by 12. What's its area? Well, again, 12 to the power of 2, or 12 times 12. And you'll get to the point where you use squares so often that you'll start to pick up real quick what are the square numbers. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16, so on and so forth. 12 usually ends up, a lot of times, becoming one of those last ones you memorize. We'll look at it here. 12 times 12. 2 times 2 is 4. 1 times 2 is 2. Drop my 0. 2 times 1 is 2. 1 times 1 is 1. And I get 4 plus 0 is 4, 2 plus 2 is 4, and 1 plus nothing is 1. 12 squared is 100, an area of 144. So we say the square of 12 is 144. Right? And the last one we have to look at is what is the square of 23? And if you're starting to sense that pattern, good. We're going to look at, to find the square of 23, we're going to say, what is 23 to the power of 2? All right, so we'll take 23 times 23, and we'll multiply. All right, 3 times 3 is 9. 2 times 3 is 6. Now I need to drop my 0 and do 3 times 2 is 6, and 2 times 2 is 4. If I add those two columns together, I get 9, 12, and 5. So I should have 23 squared, or the square of 23 is 529. What that means, one last time here, if I had a square that was 23 by 23, its area is 529 square units. So that's calculating a square. Right? We can also go the opposite direction with that. If we know that what we did here is we knew the length and the width, and we wanted to know the area of the square. We can actually go backwards and say, if we know the area of the square, what are its length and width? And we can do that because we know the length and the width has to be the same. So what we're really looking for is what's a number that's multiplied by itself equals this area. So for example, if you look at the key concept note here, a square root of a number is one of its two equal factors. We're looking at the square root of 16. Well, we know if we have a perfect square that is 16 square units, the only way to get to 16 is to multiply 4 times 4. 4 times 4 is 16. So we say the square root of 16 is 4. All right. Now, the way we write that is with this sign down here. If you take a look, it's called this little sign right here that looks like kind of like a division sign with a bend in it. All right. And we call that a radical sign. All right. We call that sign the radical sign. To go back to our notes here, is what that sign is called. That is the way in math class you will be asked to find the square root of a number, is if a number is written inside a radical sign, or this symbol right here. So let's see what that looks like. Here I want to find the square root of 64. This time I'm working backwards. I want to find the square root of 64. What I'm saying is, here's the square, the area is 64, what's its length and width? All right, now the common mistake here that we're going to dispel right away is to simply divide it by 2, find half of the number. But take a look at what happens if it were that easy. 2 goes into 6 3 times. All right, bring down the 4. 2 goes into 4 2 times. 2 times 2 is 4. I subtract, I get 0. So half of 64 is 32. So the common misunderstanding is that the square root of 64 is 32. But let's take a look at why that doesn't work. If I say the square root of 64 is 32, then in order to get the area, I have to be able to take 32 times 32 and get 64. Well, you can see that I'm going to get a much higher answer than 64 if I do this multiplication problem. I have 6 here. 2 times 3 is 6. 3 times 3 is 9. I'm going to get something well into the thousands here. 1024. So it's not simply dividing the number in half. All right, so we have to kind of start retraining our brain again to think algebraically. What we're looking for is what number times 60 times itself equals 64. 1 times 1 equals 1. 2 times 2 equals 4. 3 times 3 equals 9. Where you get to is all the way up. My brain knows that 8 times 8 is 64. So the square root of 64 then is 8. Because if I want a square that has an area of 64, because the length and width have to be the same for it to be a square, then those dimensions have to be 8 and 8. So the square root of 64 is 8. All right. Let's look at one more example here, this time with a little bit bigger number. We'll go a little bit larger and see how sometimes this has to just become a guess and check. I want the square root of 289. Again, the radical sign tells us to find the square root. So what I have is a square that has an area of 289. I want to know what are its lengths and widths, and again, because it's a square, the length and width have to be the same. So this is where it becomes a little bit of guess and check. I have to get to 289. Well, if I start with 10 by 10 square, I know that's 100. So I know the dimensions have to be more than 10, and quite a bit more than 10 by 10. I'm going to go next to 12. As we talked about, some of these squares become pretty common in your head after a while because you'll do it so many times. I know the square of 12 is 144. That's still not high enough. And the last one that comes to mind is the square of 13 is 169. Still need to go a bit higher, and it looks like we're more than 100 shy, so I'm going to go higher than that. I'm going to go up to 15. Let's try, this is where the guess and check comes in. Let's try 15 times 15. Okay, 5 times 5 is 25. 1 times 5 is 5, plus the 2 is 7. Okay, I'll drop my 0 and do 5 times 1 is 5. 1 times 1 is 1. And add those columns together. I get 225 is the square of 15. I'm still not high enough because I need to get to 289. All right, so let's go a little bit higher. Let's go up to 16. All right, let's see what happens there. If I go up to 16 times 16, I get 6 times 6 is 36. 1 times 6 is 6, plus the 3 is 9. Okay, I'll drop my 0. 6 times 1 is 6. 1 times 1 is 1. I have 6, 15, and 256. Still a little too low. All right, let's go up then to 17. All right, 17 times 17 is 49. 1 times 7 is 7, plus the 4 is 11. I'll drop my 0. 7 times 1 is 7. 1 times 1 is 1. And when I add these together, it looks like I might finally have something. There we go. I got an area of 289 using 17. So with a little bit of guess and check, right, and working my way up, I finally found that the square of 17 is 289. So that means the square root of 289 is 17. Or in other words, to go back to our original square here, I have, if the area of the square is 289, then its dimensions have to be 17 by 17. So we say the square root of 289 is 17. All right, let's look at just a couple more examples here of doing squares and square roots. Now being able to bounce back and forth, okay? Being able to bounce back and forth. So we'll look at problem number 1 here on this review page. It says find the square of each number. So to find the square of 6, I need to do 6 times 6, which equals 36. Okay. If I jump over to number 3, it says find the square of 17. So that tells me to do 17 times 17. That one we have to actually write out and do quickly. I have 7 times 7 is 49. 1 times 7 is 7, plus the 4 is 11. Drop my 0. Take a look at what happens here. This might start to look familiar. I have 289. Well, if the square root of 289, going back to one of our earlier examples, if the square root of 289 is 17, then the square of 17 is going to be 289. All right, so we can work backwards and forwards. All right, let's go back to the other direction. Here you see in example number 5, I have the number 9 with a radical sign. That means tell me the square root of the number 9. Well, what number times itself equals 9? I know that 3 times 3 equals 9. So the square root of 9 is 3. Number 7, if you take a look, it's the square root of 121. All right, the square root of 121. Now, I'm going to go back to my math sense, and I know that 10 times 10 equals 100. So I'm pretty close. Let's go up just one more and look at 11 times 11. 1 times 1 is 1. 1 times 1 is 1. Drop a 0. 1 times 1 and 1 times 1. When I add that together, there you go. So I say the square root of 121 is 11. So we can bounce back and forth. If I'm given a number and asked to find its square, I'm going to multiply that number times itself. To find the square of a number, let's go all the way back to our beginning here. To find the square of a number, we're going to multiply that number times itself. To go the opposite direction, to find the square root of a number, we're going to take the number and try to come up with what number times itself equals the number we're asked to calculate. Going back and forth with squares and square roots.